All right, today's lecture we're going to start talking about how to name organic compounds, also known as nomenclature. Now, in naming organic compounds, there's three parts to it. Essentially, there's a prefix. Okay. There's a middle letter. And there's the suffix at the end. Okay. The prefix is based on the longest carbon chain. The middle is based on the carbon to carbon bonding. Is there a single bond? Is there a double bond? Is there a triple bond? And the suffix is depending on what functional group is attached. Okay. Now, for a list of functional groups, you can look at right at the beginning of this book, like the first page in there. Yep, right past the cover. Yep. It gives you all of them right there. And we're going to start with, let's start with the prefix, and we'll come back to this stuff, the middle and the suffix and all of that. So, the prefix is based on the longest carbon chain. Okay, whatever my longest carbon chain is will determine the prefix that I'm going to use. Okay, and we're going to go up to 10. So 1, the prefix is meth. 2, okay, is eth. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept, not sept. Sept is septa. That is transportation in Philadelphia. 8 is oct. 9 is known. And 10 is deck. Okay? So that's step 1. Step 1 is, what is my longest chain of carbon? Meth, eth, prop, bute, pent, hex, hept, oct, known, and deck. If we have to go above that, we'll talk about it when we need to go above it. But for right now, 10 should suffice us for what we need. Okay, so 10. All right. Now, that being said, that takes care of the prefix. What about the middle? Okay, so the middle I had in red, the mid. A carbon to carbon single bond, the middle is an AN. Okay, or an A. We'll just go with an A. Let's just go with an A. Okay. A carbon to carbon double bond is an E. And at least one to carbon triple bond is a Y. Okay. And then your suffix. Your suffix depends all on your functional group. Okay? So your suffix depends on your functional group, and we're going to start with hydrocarbons only. And for a C to C, all I contain is hydrocarbons, carbons and hydrogens. My ending is Ne. Okay? My suffix is Ne if I'm just a hydrocarbon, whether I have a double or triple bond. I don't have anything else in me, just hydrogen and carbon. Whether I have a single bond, I'll single bond it, I'm saturated, I have an unsaturation or multiple. Okay? That's how it works. So let's put it all together. Okay? Let's put it all together. So we get a carbon chain, and let's do the skeletal structure first. All right, let's do this way first. Okay, we count up the longest chain of carbons. So 1, 2, 3, 4. There's 4 carbons each point. 1, 2, 3, 4. 4 carbons. 4 carbons. The prefix is bute. The middle is A. And the ending is Ne. So this is butane. Okay. Let's look at it from another perspective. Let's do this. 2, 3, 4, 5. Drawing all our hydrogens to show that it's just a plain old hydrocarbon. I've got 5 in a row. Pent. Okay. Single bonded carbons, A, N, E. Okay. So that's pentane. Okay, so what if we want a double bond in there? What if we want to show a double bond? Okay, so let's do that. Let's do something like this. Boom, boom, boom. Okay, 1, 2, 3, 4, 5, 6. So we got 6 carbons. Ooh, that needs 1, 1. All right. 6 carbons. That prefix doesn't change. All right, because there's a double bond, it's still hex. I have a double bond. Okay. So a double bond, that middle becomes an E. And since I'm still all hydrocarbons, okay, we'll put that NE ending. The ending is really an E. The middle is really EN, but we'll just stick the way we are right now. Okay. The thing is with hexene, though, you need to indicate where the double bond is, because this is also hexene. Okay. But they are 2 different compounds. Okay, so numbering my carbons. I want to take the shortest distance to the first thing that isn't a saturated carbon. A saturated hydrocarbon, I should say. I want to take, or the shortest distance to something that's not a carbon bonded to all hydrogens. Okay. So something that breaks away from that carbon to hydrogen to hydrogen to hydrogen to carbon bond, all single bonds. The first thing that's different from my hydrocarbons, I'm trying to explain it better than what I said, but in our case here, I wouldn't number it 1, 2, 3, 4, 5, 6. I would take the shortest distance, so we would number 1, 2, 3, 4, 5, 6. And we would number this one 1, 2, 3, 4, 5, 6. So this would be known as 3-hexene, while this is known as 1-hexene. The number, okay, the number before the double bond is how we number it. Now, there's an alternative way that's now being accepted. I could call this hexa 3-ene if I wanted to. Okay? And this would be hexa 1-ene. And the A goes in there for pronunciation purposes. Because again, the ending for alkanes, alkenes, alkynes isn't really the NE, it's really the E. Okay. So a triple bond, if I were to have one, something like this. Okay. I've got 3 carbons. Stick with the colors, I guess. Prop. I do have a triple bond. Y. Add the Ne to it. Propyne. I could put the number out there, but it's overkill because it can't be anywhere else. So 1 propyne. All right, so let's look at a little bit more challenging. Okay. Now, let's do a line drawing. And I'm going to do it this way. Boom, boom, boom. And put a double bond here. Now, we have to remember with our line drawing that the new way, there's actually a carbon here and here. So it's 1, 2, 3, 4, 5, 6 carbons the new way. Okay. So this is 6 carbons, hex. There is a double bond, E. Okay, and then Ne for our ending, because there's no other difference. It's all hydrocarbons. 1, 2, 3. 1, 2, 3. So this is 3 hexene. Let's try another one. Okay, I just want to show you the line way. Let's do it this way. Do, like that. Okay. That needs that. That has 4. This needs 1. Okay. We count how many we have for bute. We have a triple bond, Y, Ne. Now don't worry about your numbers or anything until after you have the compound named. This is butyne, but now we have to number it. And what students want to do is, we're used to reading left to right, say that this is 1, 2, 3, 4, and this is 3 butyne. That's wrong. The numbering has to go from right to left. 1, 2, 3, 4. And this would actually be 1 butyne, or the new way of naming it, buta-1-ine. Both are accepted by IUPAC. Okay. The International Union for Physics and Applied Chemistry came up with this naming mechanism, or naming system, I should say. Okay, so that's buta-1-ine or 1-butyne. I learned this way. This is the relatively new way. Okay. All right. Now, that being said, let's add a little bit to it. All right, let's do this. 3, 4. Let's say we have something like this. We want to count our longest chain, but we have this hanging off on the side. Okay. Our longest chain, you would say, is 1, 2, 3, 4. So you'd say, okay, this is bute. All right. They're all singly bonded, A and E. So that's butane. But what do I do about this little side chain? Okay. This little side chain, we count how many are in the side chain. We use our prefix and add YL. So for side chains, use the prefix and add YL. So this is known as ethyl butane, right? And if we were doing this, we'd say it's ethyl butane, and we'd have to say where ethyl is. So we would number our carbons 1, 2, 3, 4. Ethyl butane, and it's off the second, so 2-ethyl butane. And you'd write this down in the exam, and I would do this to it. Okay? Because it's not 2-ethyl butane. And I'll explain why it's not 2-ethyl butane. Our rule is we need our longest chain of carbons. And our longest chain is not this one that's going horizontal at all. Our longest chain, I'll finish my C's off here that I erased. Our longest chain is actually right there. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. No matter how you want to number it, it's going to work out the same. That's our longest chain. This isn't a butane. This is really 1, 2, 3, 4, 5. Pent, all bonded together. ANE. It's pentane. We do have a group hanging off. It's 1, so it's methyl. 1 carbon, methyl, pentane. And what carbon is it on? It's on the 3rd, so we call this 3-methylpentane. So what I'm trying to show you here is the longest chain doesn't have to be written this way. It could tail off, so the key is find your longest chain. Okay? Let's try another one. We'll do it this way. And we'll do that. And we'll do this. Okay. First thing we count is our longest chain. So I'm going to count here. 1, 2, 3, 4, 5, 6, 7. Okay, 7. That's what I got to beat. If I start here, this is 1, 2, 3, 4, 5, 6, 7. So they're both the same, 7. How about here? 1, 2, 1, 2, 3, 4, 5, 6. That's not longer. 1, 2, 3, 4, 5, 6. So 6 isn't going to cut it. 7 is going to be the longest. So we're going to call it hept. They're all singly bonded, A-N-E, heptane. All right. Since they're all singly bonded, heptane, A-N-E. Now, I've got a little chain coming off on that side. I've got a chain coming off on this side. And if you want to see it this way, here's what it would look like as the line structure. 1, 2, 3, 4, 5, 6, 7. Second, third, fourth. All right, right here would have this bonded to that. All right, this is what this would look like from the skeletal structure to the line structure. I've got 2 groups. One has 1 carbon on it. That's a methyl group there. And over here, this has 2 on it. This is an ethyl group. Okay. A methyl group and an ethyl group. Now I have to number my carbons. Shortest distance. So I don't want to go 1, 2, 3, 4 or 1, 2. I want to go this way. This is the shortest distance to something that's different than a saturated hydrocarbon. It has something hanging off. Still saturate all single bonds, but not in the straight chain. Here we go. What do I put first? Do I call this 2-methyl 4-ethyl heptane or 4-ethyl 2-methyl heptane? And the answer is it goes alphabetical by the side chain. So this would be 4-ethyl, comma, 2-methyl, comma, heptane. Okay, so alphabetical order by functional group coming off the side, or by side chain, not functional group, but side chain. Okay. All right, let's try another one. I've got, let's do this one. Let's do a line, a skeletal again. But now I'm going to do a triple bond. Now, with a triple bond, it's not like the double bond. There are no 2 carbons assumed here. I don't know why. Again, I explained this in our last lecture. So this one only has 1, 2, 3, 4 on it. And let's do this. something like that. Okay. So we count. I've got a triple bond, and I've got 4 carbons. 1, 2, 3, 4. Now, if I go this way, 1, 2, 3, all right, 1, 2, 3, 4, 5. Okay. But I have to include a double or triple bond. Even if this was a longer chain, let's say it was 10 this way, I've got to include the triple bond in my chain. So let's try this way. 1, 2, 3, 4, 5, 6. So this was 4, this is 6, and this way was 5, but we can't go that way. We have to include the triple bond. Okay, so we got 6. 1, 2, 3, 4, 5, 6. Okay, so 6. So we are definitely hex. Since we have a triple bond, we're YNE. But I've got to say where that triple bond is. So do I count this way? 1, 2, 3, 4. So it's 4 hexine. Or do I go this way? 1, 2, 2 hexine. I'm going to go shortest distance. Shortest distance to that triple bond. 1, 2. That's the shortest distance to something that's different. 2 hexine. Okay, but I also have, what is this over here? I've got an extra carbon hanging off of this one here. This is a methyl group hanging off over here. What number of carbon is on? Well, if that's 2, this is 3. So it's 3 methyl, 2 hexine. Or you can write it the new way, and this is why the new way came into effect, so that didn't get all mumbo-jumbled up front. 3 methyl hexa 2 ine. Both ways are acceptable. Okay. And I know I'm throwing a bunch at you with alkanes, alkenes, alkynes, but if you can get alkanes, alkenes, alkynes down, all we're going to do is follow this same method over and over and just add a new functional group that has a new ending. Okay. So, let's try something else. Let's do this. We'll go back to this way. 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And let's say we do off of this one. We have that. And off of this one we have that. And we go. Always make sure your carbons are making at least 4 bonds. Okay, longest chain. 1, 2, 3, 4, 5, 6, 7, 8. How about if I go this way? 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4. No. 1, 2, 3, 4, 5, 6, 7. No. 8 this way. Okay, they're all singly bonded. Octane. Oct. A-N-E. Okay. Which way am I going to number? 1, 2, 3. 1, 2, 3, 4. I'm going to number this way because it's the shortest distance to what's different. 4, 5, 6, 7, and 8. They're both methyl groups. Okay. Since they're both methyl groups, I've got to say that both of them are there. And what we say is 3, 5, dimethyl. Okay. Now, that being said, if there's a di or a tri or something in front of this, okay, that doesn't count towards the alphabetical order. So let's say there was an ethyl group over here or something. The ethyl would still come before the methyl. Even though the D is before, the letter D is before letter E in the alphabet, but we'd go by the methyl. So this would be 3,5-dimethyl. I also want to point this out, and I'll write another methyl group. Imagine if, this was taken away, and it was drawn on here. Well, that didn't work. It was drawn. I want to use a different color though. I'll use blue. No, let's use this blue. It was drawn on here. Okay. In order to name this, it would still be octane. I have to write it like this: 3,3-dimethyl. And basically what you're telling somebody is that there's 2 methyl groups on the 3rd carbon, and we have 8 carbons in our chain. And that's a terrible looking methyl there. YL. Methyl octane. So 3,3-dimethyl octane. Okay. All right. Speaking of dyes and tris and things like that, let's look at this one. Okay, before you start worrying about things and everything, count your longest chain, 4. 4 is bute. Now, I've got 2 double bonds. One on the 1st carbon and one on the 3rd carbon. If I have that, I'm known as a diene. Butadiene, and I have to say where they are. 1,4. Or 1,3, sorry. 1,3 butadiene. You can also do the new way. Buta 1,3-diene. I like this way. This is the way I learned. 1,3-butadiene is what this compound would be. Okay. 2 more things I want to point out in this video, and we're getting about to the half-hour point here. If my chain, now I want to show you something here. 1, 2, 3, 4, 5, 6, 7. Let's do that. Okay, and right here in the center, let's say we have a propyl group coming off. Okay, 1, 2, 3. 1, 2, 3 there, and how many are you making? You need 1 more. And all around. Hydrogens for everybody. I'm buying. Okay, here we go. Let's count our longest chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, and 1, 2, 3, 4, 5, 6, 7. So either way we go, we're getting 7, 7, 7. All right, and it doesn't matter. We have a 3rd carbon, a 3-carbon chain bonded to it. So we have 7. 7 is hept. They're all singly bonded. It's heptane. What's my shortest distance to that? 1, 2, 3, 4. So this is 4, 3, 2, 1. So we would say it's 4 propyl heptane. Okay? Hopefully you're getting this by now, but if not, you can email me. And we're going to just continue doing this over the next couple days, or the next lecture and stuff, so it'll be all right. But let's draw this same compound. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Draw this all in. All right, on the 4th carbon, which is this one right here, we're going to do this. But now, here's my propyl group. Okay. And my propyl group is attached to the middle carbon instead of being attached to the end carbon. Okay. And I need to indicate that. I need to indicate where it's attached. All right, that it's attached to the 2nd carbon, not the 1st carbon in the chain. So we still call it heptane. It's still on the 4th carbon, but since it's attached to the middle, it's known as iso if it's attached to the middle. Isopropyl heptane. Let me write that a little bit better here. Isopropyl. And I did it again. You get it. Propylheptane. Okay. The other place this happens, I just want to show you. Let's say I have a carbon chain. All right. And the letter R represents a carbon chain. So let's say we have a carbon chain, and coming off of it, I have 4 carbons. Okay, so we have a long carbon chain. This is known as a butyl group. Okay. If I have my carbon chain, but this time it attaches to, and I'll draw the other hydrogens in just for OCD purposes. But let's say it attaches to the second carbon here. Okay. One there. It attaches to the second carbon. Well, it's not an iso because it's not the middle, because there's 2 there. So we call this sec-butyl, meaning it's attaching to the second carbon of the butyl group. Okay. All right. So that was one more topic I wanted to talk about. And the last one I want to talk about that deals with hydrocarbons is if they essentially, all right, make a cyclic structure. You still count the carbons in the longest chain, 1, 2, 3, 4, butane, and you put the word cyclo in front of it. So this is, if I could spell tonight, cyclobutane. This is 3. This is cyclopropane. What if I had something like this then? You might ask. Okay, well, if you have something like this, 3 carbons, but it's a double bond. So this would be cyclopropene. And you can put 1 cyclopropene, but it's overkill because this automatically, or that one, has to be the number 1 carbon. So let's try this. Something like that. Okay, I have 1. And cyclo, it's better, it's a lot easier to draw cyclic alkanes and alkenes and things like that via the skeletal structure versus the line structure, as you can see, because this can get really complicated. All right, and I said that in the slides too, but let's take a look at this. There's 1, 2, 3, 4, 5, 6 carbons, so I know I have a hex. I've got to start at one of the double bonds, so this is 1, 2, 3, 4, 5, and 6. Now I know if you go this way, 1, 2, 3, it gets there faster, but you have to include the double bond in your counting. Okay, so how would I name this? Well, it's cyclohexene. And where is it? 1, 4 cyclohexene. If you really want to get complicated, you could call it 1, 4, and no one does this, but technically if you're following my UPAC, you could. 1, 4 cyclohexadiene, because there's 2 double bonds. Or you could do this the new way. Cyclohexa 1, 4 ene or diene, however you want to. But the common way you usually see, the new way of naming kind of dies with the cyclic compounds, and you end up with 1, 4 cyclohexene. Okay. You can't have ring structures with triple bonds. They're linear. They're not going to be ring structures. So let's try a couple out here. And that's what we'll end the video. Now for homework, you're going to have to go through this book. The only thing I don't like about this book is that it doesn't do chapters of nomenclature by themselves. So you're going to have to go in your alkenes, alkanes chapters to find additional naming stuff. The Blackboard has it up there too. I have some worksheets I believe I have up there. Okay, so let's look at one. Let's do this. And you should be able to go in both directions. All right, you should be able to look at a structure. You should also be able to look at it and say, 3-ethyl cyclo pentane. Or pentene, I should say. 3-ethyl cyclopentene. Let's look at this one here. Put a group there. We'll put a group there. I'll put a group like this. And we'll put one more like this. Okay. Now, let's see what our longest chain is. After I draw in all my hydrogens, we'll see how this works out. Don't freak out. Take your time, count your carbons, get your longest chain. I know it looks like a lot of stuff going on here, but don't worry about it. Count your longest chain. So let's start here. 1, 2, 3, 4, 5, 6. If I go this way, it's 6. If I go this way, it's going to be 6. 1, 2, 3, 4, 5, 6, or that. So those are 6. Okay, and it's 6 this way. So 6 is to beat. 1, 2, 3, 4, 5. That's not going to work. 1, 2, 3, 4, 5, 6. Could possibly work. All right. 1, 2, 3, 4, 5, 6. Still not bigger than 6, so I'd rather just stay with this linear thing, and that'll work. 1, 2, 3, 4, 5, 6, 7. We have a winner. We have a winner by going, and I'll use a different color. We have a winner by going this way. Okay, so we've got 7. So we've got to number it. Okay, we've got to number it. Shortest distance, I could either go here or here. I'm going to go this way because they're both 1 or 2, but I'm going to go the one that has the die on it. There's 3, there's 4, here's 5, here's 6, here's 7. Okay, so what do we got here? Okay, I've got 7 carbons in a row. They're all singly bonded. Let's call it heptane. Sounds good to me. Let's look at our functional groups or our side chains. I've got a methyl. I've got a methyl. I've got a methyl. And I've got a methyl. I've got 4 methyls. Okay. All right. And what else do I have? I have an ethyl group up top on number 4. Okay. I've got an ethyl group up on number 4 here. Here's an ethyl. Well, ethyl's going to come first. So it's on number 4 alphabetically, ethyl or methyl. So we have 4 ethyl. Okay. Then what do we have? 2, 2, 5, and 6 have methyl groups on it. So 2, 2, 5, 6, tetra. Tetra means 4. Tetramethyl heptane. So if I break this down, it's telling me that on the 4th carbon I have an ethyl group. On the 2nd carbon I have a methyl group and another methyl group. On the 5th I have a methyl group. On the 6th I have a methyl group. And I need 7 carbons in a chain. Okay, so let's try this down here. What is it telling me? It's saying cyclopentene. Okay, cyclopent means 5 carbons. All right, so I'm terrible at drawing pentagons. I think I did it. There we go. 1, 2, 3, 4, 5. Okay, so there's my 5 carbon ring. It's a pentene. You pick which one you want to be the first carbon. You want that to be the first carbon? Okay, so this is 1, 2, 3, 4, 5. And off the third carbon, I have an ethyl group coming. So 1, 2, there's my ethyl group. So there's 3 ethyl cyclopentene. Let me do a couple more here. Let's do a couple more of the words. Let's do this. I'm just going to make something up off the top of my head. We'll see if it works out. 2, 3, di, I don't want P there, ethyl, 5, 5, dimethyl, okay, so 3, 3, 2, 3 diethyl, 5, 5 dimethyl, 3, no, let's not use 3, let's use 7, yeah, octene. Now let's see if this follows IUPAC naming and see if this is right, or should we correct it and name it something else. So let's draw it out. So I have octene. I need 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. On the 7th carbon, I have an octene, according to this. So 1, 2, 3, 4, 5, 6, 7. Let's just call them that. Okay. Now I could already see, and maybe you already see, calling it 7-octene isn't going to work, but let's just follow what they have written. Because a lot of the questions are, in the book, correct the IUPAC name. So there's 7-octene. Now, 2, 3 diethyl. Off the 2nd carbon is going to be 2. And off the 3rd carbon, we'll go this way too, even though that probably would never happen. All right. And then off the 5th carbon, there's a 2 methyl groups. Okay, so this would be 8 carbons on the 7th, a double bond, an ethyl group on 2, an ethyl group on 3, and an ethyl group, or 2 methyl groups on 5. So let's see if this makes sense. We already know that this is wrong because the numbering should go this way. But let's see if we have our longest chain. 1, 2, 3, 4, 5, 6, 7, 8. I already have 9 there. If I go that way. 1, 2, that's not going to help me. So 9 is actually going to be my longest. My longest chain is actually going to be this right here. Okay. So let's get rid of the numbering. And let's see how we do here. So we have a double bond, and we have 9 carbons. And the double bond is on the 1st carbon. So I'm going to number it this way. 3, 4, 5, 6, 7, 8, 9, because that's my longest chain. So I definitely have a 1 known ene out there. Now, what else do I have? I have a methyl group and a methyl group. I have an ethyl group here and a methyl group here. So I've got 6 ethyl. So this is wrong. I have a 6 ethyl, a 4, 4, 7 trimethyl. A 4, 4, 7 trimethyl. one nonene. So, what can I tell you guys about this? Take your time, break it down. No matter how complicated it looks, the name will get you to the right structure, or the structure will get you to the right name if you follow the rules of longest chain and shortest numbering. Okay? So again, your homework, like I said, look for alkanes, alkenes, alkynes in the book. They're all over the place. They don't follow a specific order. So each chapter with alkane, alkene, alkyne, they talk about the nomenclature that way. Hopefully this helps. If not, send me an email, and then on Thursday we'll continue on with this. All right, guys, have a great day. Take it easy.